we are going to study an initial value problem in integral calculus. So what we're given is the derivative of f and a measurement on f itself. So f of a equals b. That would be an ordered pair on the graph of f. If we have both of those things, we can calculate the function f of x. So this example, find f of x given f prime equals 2x and f of 3 equals 10. So if we have f prime, we can take the antiderivative and get f of x. So the antiderivative of 2x is x squared plus c. Now, what we have is that when x equals 3, f of x equals 10. And this is just rewriting what we have up here. F of 3 equals 10. We're going to replace x with 3. And replace f of x with 10. What we can do here is solve for the constant. So in this situation, if you have an initial value, you can solve for the arbitrary constant and get the exact value for that. So this is c equals 1. The answer to the question is f of x equals x squared plus 1. Now, let's consider the graph of x squared. We've answered the question. I'm not going to ask you to graph the function here, but just for the sake of learning, so this is y equals x squared plus a constant for c equals 0, so a parabola at 0, 0. Now, what we have done is we've calculated the function x squared plus 1, which gives us the ordered pair of 3, 10. So 3 comma 10 isn't on y equals x squared, it's on y equals x squared plus 1. So the information we are given has to work for both. It has to be the antiderivative of 2x, and that function has to pass through 3 comma 10. And in doing so, we have calculated the exact function x squared plus 1 that does that. If you leave c as arbitrary, such as when calculating the antiderivative, that's called the family of antiderivatives and accounts for any vertical shift of that function. In this particular problem, we are given the initial value, which allows us to solve for the exact function.